the assumption that the main reason for using ground fault circuit interrupters, or GFCIs, in bathrooms is primarily because of water is incorrect. While water is a contributing factor, it is not the primary reason. The main reason GFCIs are required in bathrooms is to provide protection against electrical shock. Bathrooms are inherently damp environments where electrical appliances and fixtures are frequently used in close proximity to water sources. This situation significantly elevates the risk of electrical shock, which can have fatal consequences. GFCIs are specifically designed to detect imbalances in the flow of electrical current within a circuit. These devices are incredibly sensitive and can detect even very small leakages of current, as low as 5 mA. Upon detecting such a leakage, a GFCI will instantly interrupt the power supply to the circuit. This rapid interruption prevents the potentially dangerous flow of electricity through a person's body, thereby averting electrical shock. While water is not the single most important factor driving the requirement for GFCIs in bathrooms, it does substantially increase the overall risk of electrical shock. Water is a good conductor of electricity. If water comes into contact with electrical components or wiring, it can create a pathway for electrical current to flow through a person who is also in contact with the water, resulting in a shock. Now, let's consider the question of why GFCIs are not universally required for floor receptacles. The National Electrical Code, or NEC, does not specifically mandate the use of GFCIs for all floor receptacles. However, the NEC does require GFCI protection in bathrooms, kitchens, and other areas where there is an elevated risk of contact with water or moisture. From a practical safety standpoint, even though GFCIs are not always required for floor receptacles by code, electrical safety experts often recommend their use. The reason for this recommendation is that floor receptacles are susceptible to spills or moisture from routine activities like mopping or cleaning, which can create a potential electrical hazard. Floor receptacle covers are often used to provide an additional layer of protection against moisture and debris. However, it's important to recognize that these covers are not a complete substitute for GFCI protection. Covers can become dislodged, damaged, or may not be properly used, leaving the receptacle vulnerable to contact with water or other conductive materials. Similarly, outdoor receptacles are required to have GFCIs. Although these receptacles also typically have covers, the NEC mandates GFCI protection in these locations due to the increased risk of exposure to rain, snow, and other forms of moisture. The presence of these environmental factors makes the risk of electrical shock significantly higher in outdoor settings. In conclusion, while the presence of water is a significant risk factor for electrical shock, it is not the only reason why GFCIs are essential in bathrooms. The primary reason for requiring GFCIs in bathrooms is to provide comprehensive protection against electrical shock, which could occur in both wet and dry conditions. While the NEC may not explicitly require GFCIs for all floor receptacles, their use is highly recommended due to the potential risk of moisture contact and the possibility of covers being compromised. The fundamental principle is to minimize the risk of electrical shock in any situation where there is a reasonable possibility of contact with electricity and a path to ground. Here's a more detailed breakdown of the concepts discussed. Firstly, the purpose of a GFCI is to protect people from dangerous electrical shocks. It does this by monitoring the current flowing in a circuit. If there is a difference of even a few milliamps between the outgoing and returning current, the GFCI trips, cutting off the power almost instantly. This difference in current indicates that some electricity is leaking, potentially through a person. Secondly, the reason bathrooms are high-risk areas for electrical shock is due to the combination of water and electricity. Water is an excellent conductor of electricity, and bathrooms often have sources of water such as sinks, showers, and bathtubs. If someone is using an electrical appliance in the bathroom, like a hairdryer or shaver, and it comes into contact with water, the person could receive a severe, even fatal, electrical shock. Thirdly, the NEC mandates the use of GFCIs in bathrooms and other areas where water is present to minimize this risk. This requirement is based on the understanding that even a small amount of water can create a dangerous electrical pathway. Fourthly, while floor receptacles may not always be subject to the same GFCI requirements as bathroom receptacles, they still pose a risk. Floors can get wet from spills, cleaning, or other sources. If a floor receptacle is not GFCI protected and comes into contact with water, it could create a shock hazard. Fifthly, floor receptacle covers are designed to provide some protection against moisture and debris. However, they are not a foolproof solution. Covers can be broken, left open, or improperly installed. Therefore, they should not be considered a substitute for GFCI protection. Sixthly, outdoor receptacles are another area where GFCIs are essential. Outdoor environments are naturally exposed to rain, snow, and other forms of moisture. This makes the risk of electrical shock significantly higher, which is why the NEC requires GFCIs for all outdoor receptacles. Seventhly, the NEC, or National Electrical Code, is a set of standards for safe electrical installation and wiring in the United States. It is updated every 3 years to reflect the latest advancements in electrical safety. Understanding and following the NEC is crucial for ensuring the safety of electrical systems in homes and businesses. Eighthly, the sensitivity of GFCIs is a critical factor in their effectiveness. They are designed to trip at very low current levels, typically around 5 mA. This is far below the level that would cause serious injury or death. The quick response time of GFCIs, usually within a fraction of a second, further enhances their ability to prevent electrical shocks. Ninthly, it's important to note that GFCIs do not prevent all electrical shocks. They are primarily designed to protect against ground faults, which occur when electricity leaks to ground. GFCIs do not protect against shocks that occur when someone comes into contact with both the hot and neutral wires of a circuit. Tenthly, the installation of GFCIs is a relatively straightforward process, but it should always be done by a qualified electrician. Improper installation can render the GFCI ineffective or even create a new hazard. Always follow the manufacturer's instructions and local electrical codes when installing GFCIs. In summary, GFCIs are a critical safety device that protect people from electrical shocks, particularly in areas where water is present. While floor receptacles may not always be subject to the same GFCI requirements as bathroom receptacles, they still pose a risk and should be carefully considered for GFCI protection. Always prioritize safety and consult with a qualified electrician to ensure that electrical systems are installed and maintained properly. To further clarify the NEC requirements, the NEC Article 210.8 provides the specific rules for GFCI protection. 210.8 covers dwelling units, stating that all 125 volt through 250 volt receptacles installed in bathrooms, garages, and outdoors shall have GFCI protection for personnel. This is because these locations are prone to moisture or contact with the ground. 210.8 B covers other than dwelling units, which requires GFCI protection for 125 volt through 250 volt receptacles in locations such as bathrooms, kitchens, rooftops, and outdoors in commercial and industrial settings. These requirements are more stringent due to the higher potential for electrical hazards in these environments. Now, let's explore the technical aspects of how a GFCI works. A GFCI constantly monitors the current flowing through the hot and neutral wires of a circuit. Under normal conditions, the current flowing through these wires should be equal. If there is a difference of 5 mA or more, the GFCI detects this imbalance and quickly trips, cutting off the power to the circuit. This imbalance indicates that some of the current is leaking, potentially through a person who is in contact with a live electrical component. The GFCI's ability to detect such small current leakages and respond so quickly is what makes it an effective safety device. The GFCI operates on the principle of differential current measurement. It uses a sensing transformer to measure the current in the hot and neutral conductors. The magnetic fields produced by these currents should cancel each other out if the currents are equal. However, if there is a ground fault, some current will return through a different path, creating an imbalance in the magnetic fields. This imbalance is detected by the sensing transformer, which then triggers the GFCI to trip. There are two main types of GFCIs: receptacle type and circuit breaker type. Receptacle type GFCIs are installed in place of standard electrical outlets and provide GFCI protection only to that specific outlet. Circuit breaker type GFCIs are installed in the electrical panel and provide GFCI protection to the entire circuit. Both types of GFCIs offer the same level of protection, but circuit breaker type GFCIs can be more convenient for protecting multiple outlets or hardwired appliances. The NEC also addresses the installation and placement of receptacles in bathrooms. According to NEC 210.52, at least one receptacle outlet must be installed in bathrooms within dwelling units. The receptacle must be located within 3 feet of the outside edge of each basin. This requirement ensures that there is a convenient and safe place to plug in electrical appliances such as hair dryers and electric shavers. The NEC further specifies that the receptacle must be GFCI protected to minimize the risk of electrical shock. In addition to GFCI protection, the NEC also requires that receptacles in bathrooms be tamper-resistant. This is to protect children from inserting objects into the receptacle and receiving an electrical shock. Tamper-resistant receptacles have internal shutters that prevent objects from being inserted unless both prongs of a plug are inserted simultaneously. The NEC also addresses the use of extension cords in bathrooms. Extension cords should be avoided in bathrooms whenever possible, as they can create a tripping hazard and increase the risk of electrical shock. If an extension cord must be used, it should be heavy-duty and listed for use in wet locations. It should also be unplugged when not in use. The installation of electrical wiring and devices in bathrooms must comply with all applicable codes and regulations. This includes the NEC, as well as any local electrical codes. It is important to hire a qualified electrician to perform any electrical work in a bathroom to ensure that it is done safely and correctly. Improperly installed electrical wiring can create a serious fire hazard and increase the risk of electrical shock. In addition to the requirements for receptacles, the NEC also addresses the installation of lighting fixtures in bathrooms. Lighting fixtures must be located at least 8 feet above the top of the bathtub rim or shower stall threshold. This is to prevent them from coming into contact with water. Lighting fixtures that are located within 8 feet of the bathtub rim or shower stall threshold must be listed for use in wet locations. These fixtures are designed to be resistant to moisture and corrosion. The NEC also requires that exhaust fans in bathrooms be GFCI protected. Exhaust fans are used to remove moisture from the air, which can help to prevent mold and mildew growth. However, exhaust fans can also create a shock hazard if they come into contact with water. GFCI protection can help to prevent this from happening. The NEC also addresses the use of electric heaters in bathrooms. Electric heaters must be permanently installed and located at least 3 feet away from any water source. They must also be GFCI protected. Portable electric heaters should not be used in bathrooms, as they can create a fire hazard and increase the risk of electrical shock. The NEC also addresses the installation of electrical panels in bathrooms. Electrical panels should not be located in bathrooms, as they can be exposed to moisture and create a shock hazard. If an electrical panel must be located in a bathroom, it should be enclosed in a weatherproof enclosure. The NEC also addresses the use of flexible cords for appliances in bathrooms. Flexible cords should be kept as short as possible to prevent tripping hazard. They should also be protected from damage. Flexible cords should not be run under rugs or carpets, as this can cause them to overheat and create a fire hazard. The NEC also addresses the use of multi-wire branch circuits in bathrooms. Multi-wire branch circuits are circuits that share a common neutral wire. These circuits can be used to supply power to multiple receptacles or lighting fixtures. However, they must be carefully wired to prevent overloading the neutral wire. Overloading the neutral wire can cause it to overheat and create a fire hazard. The NEC also addresses the use of arc fault circuit interrupters, or RFCIs, in bathrooms. RFCIs are devices that detect arcing faults in electrical wiring. Arcing faults can cause fires. The NEC requires GFCIs in many areas of the home, including bedrooms, living rooms, and dining rooms. However, GFCIs are not typically required in bathrooms, as GFCIs provide adequate protection against electrical shock. In addition to the NEC requirements, there may also be local electrical codes that apply to the installation of electrical wiring and devices in bathrooms. It is important to check with the local building department to determine what these codes are. The NEC is a comprehensive set of standards for safe electrical installation and wiring. Following the NEC can help to prevent electrical shocks, fires, and other electrical hazards. It is important to consult with a qualified electrician to ensure that all electrical work is done safely and correctly. And as a reminder, 210.8 covers dwelling units, stating that all 125 volt through 250 volt receptacles installed in bathrooms, garages, and outdoors shall have ground fault circuit interrupter protection for personnel, while 210.8 B covers other than dwelling units, which requires GFCI protection for 125 volt through 250 volt receptacles in locations such as bathrooms, kitchens, rooftops, and outdoors in commercial and industrial settings. Now with that information, here is a quick summary. 1. GFCIs protect against electrical shock by detecting current imbalances. 2. Bathrooms require GFCIs due to the combination of water and electricity. 3. The NEC mandates GFCIs in bathrooms and other wet locations. 4. Floor receptacles, while not always required to have GFCIs, pose a risk due to potential moisture. 5. Receptacle covers offer some protection but are not a substitute for GFCIs. 6. Outdoor receptacles require GFCIs because of exposure to rain and snow. 7. The NEC sets standards for safe electrical installation. 8. GFCIs trip at very low current levels to prevent injury. 9. GFCIs primarily protect against ground faults. 10. Hire a qualified electrician for GFCI installation. Understanding these points ensures safer electrical practices. Remember to consult the NEC for specific requirements and always prioritize safety.